again. My name is Jim Chisholm. I'm a former regional councillor with the Professional Engineers of Ontario. I'm also the president of the SCORE Metropolitan Toronto Toastmasters. So welcome to this seminar on the topic of engineers as leaders in sustainability through practice. This is the second seminar of a series of seminars on the theme of developing engineering leaders. Engineers have a huge responsibility to serve the public interest by safeguarding life, property, economic interests, public welfare, and the environment. This seminar series aims to highlight the importance of engineering taking a bigger leadership role in serving the public interest. It hopes to leave you with the personal challenge of being one of those leaders. I'd like to thank the sponsors of this seminar, foremost the West Toronto chapter of the PEO, who are the lead sponsor of this seminar, the Brampton, Toronto Humber, Oakville, York, Kingsway, and East York chapters as well. I also like to thank the SCORE Toronto Metropolitan Toastmasters Club and the Toronto Engineering Club of Speakers, TEX for short, Toastmaster Club. And to chair this meeting and start things off is the president of TEX, Amanda Dailey. So without further ado, Amanda.
Thank you very much, Jim. Hello, everyone, and good evening. I'm Amanda Dailey, part of the organizing committee for this seminar. I would like to start today's event by acknowledging that we are meeting on Aboriginal land that has been inhabited by Indigenous peoples from the beginning. I want to show my respect for their contributions and recognize the role of the treaty in making what is now Ontario. Hundreds of years after the first treaties were made, they are still relevant today. I'm grateful for the opportunity for us to meet here and thank all of the generations of people who have taken care of the land for thousands of years. For tonight's meeting, there are 4 guest speakers and an audience interactive portion. During the guest speakers' presentations, we will be collecting questions using Slido, which will be linked in the chat. Our first guest speaker, David Lapp, will be providing an engineering perspective on sustainability. Denis Isabel will discuss sustainability in the mining industry. Next, Frise will present sustainability in the automotive industry. Dicaire will discuss sustainability in housing. And then David will provide some final thoughts on sustainability and engineering. For the interactive portion of the evening, Darren will lead us through a Toastmasters-inspired activity called Table Topics, where we want to hear some of your thoughts. And we will conclude the meeting with final remarks from the PEO and the organizing committee. I'm happy to pass the stage over to Cristy, who will introduce our first speaker.
Thanks, Amanda. Hello, everyone. I'm Cristy, the seminar organizing committee member. I have a background of water resources engineering and civil engineering, and I'm an advocate for climate action, sustainable development, and DEI. It is my honor to introduce today's first speaker, David Lapp. Welcome, David. David Lapp is a professional engineer who graduated with a Bachelor of Applied Science in Geologic Engineering from the University of Toronto in 1978. Following a career of nearly 20 years in consulting engineering, David joined Engineers Canada in 1997, and for the next 23 years, he assumed a variety of roles in engineering qualifications and international affairs, co-authoring several national and international practice guidelines related to sustainability, environmental stewardship, and climate change. In this capacity, David was the project manager for the development, implementation, and ongoing program operation for the PIVIC protocol, a process to assess infrastructure climate risk and vulnerabilities. In September 2022, he joined the Institute for Catastrophic Loss Reduction as a part-time senior advisor for resilient infrastructure for the next 15 months. In September 2022, he joined the Climate Risk Institute as an associate. David is a fellow of Clayton Academy of Engineers, a fellow of Engineers Canada, and holds the Infrastructure Resilience professional credential. In 2018, he was given an award for engineering excellence from Professional Engineers Ontario for his work on climate change and engineering, as well as an Engineering Excellence Award in the same year from the PEO Ottawa chapter. Now it's my turn to pass the torch to David.
Thank you, Cristy. I'm going to ask Amanda to sort of run through the slides with me, so that'd be great. And we'll start off at the beginning. So we'll just get to the top of the presentation there. And it just has a few birds flying in here, so just the graphic, interactive graphic here that comes out of it. So I'll just start off. The definition of the practice of engineering in Ontario through the Professional Engineers Act explicitly includes reference to our responsibility to safeguard life, property, economic interests, the public welfare, and the environment in all acts that constitute engineering practice to serve the public interest, as was mentioned previously. This creates an imperative for engineers to incorporate this responsibility into their practice. But how can this responsibility and obligation be implemented practically by the professional engineer? Well, the answer is for engineers to think sustainably and incorporate sustainability principles into their practice, and to be ever mindful of the long-term impacts of their work and projects in society, the environment, and the economy. This responsibility requires us to assume a leadership role while working closely with other professionals, practitioners, and the public to achieve sustainable engineering works. Sustainable development and sustainability is an evolving element of engineering practice that is more comprehensive and anticipatory and supersedes the narrower, more discipline-specific activity of protecting the environment. The availability of energy, water, as well as other non-renewable and renewable resources are at risk and thereby threaten the safety and quality of life of the public in Ontario, Canada, and indeed many regions and areas of the world, now and certainly in the future. The Earth's carrying capacity is being overloaded in many ways. We must help maintain the viability of our ecosystems, as well as assure that the well-being of future generations is not compromised by our activities today. This presentation that I'm about to give you looks at sustainability from the point of view of engineering and its implications for engineering practice, and how we have a responsibility and capacity to assume a leadership role. So the next slide, which is after the title slide there, Amanda. So so what we wanted to do first of all is to talk a little bit about sustainability and sustainable development. What do we mean by that? In fact, I think, is there one slide up, Amanda, just to, I think, oh, that's going down, going up. Sorry. Sorry about that. So first of all, this is about sustainability. So we need to define these terms and just to make sure we know what we're talking about. These terms are not the same, but they're tied together. There are numerous definitions of sustainability, and one is shown on this slide. In essence, sustainability is the ability to meet the needs of the present without compromising the ability of future generations to meet their needs, and to consider the environmental, social, and economic needs, or the so-called triple bottom line, in these three areas that are referred to. Implementing these processes requires coordinated management of these, requiring good communication and consultation with affected parties. Often this element is referred to as governance, and the alternative acronym to the triple bottom line, or TBL, is ESG. You've probably heard that in the literature and so forth. A very current and topical way of looking at this, which stands for environment, social, and governance. Implicit in this description is that the economic factors in the triple bottom line are included and inherent in all these elements of ESG. Next slide. So sustainable development. Well, it's been around for more than 35 years. The concept grew out of a more limited goal of protecting the environment and pollution detection and treatment, as I mentioned earlier. The most widely known accepted definition was tabled by the Brundtland Commission in 1987, which is listed on the slide there. And it concentrates on the methods and the strategies to achieve the state of sustainability, where as applied to development. Sometimes you don't have development, but you want to sustain, for example, your environment. So that's kind of a distinction between the two. Next slide. So with the pillars, which we call environment, economics, and society, or societal concerns, you can see in this slide that there's an intersection of all three elements, the middle piece being sustainability. You have activities that are unique to each of those pillars, and then you have intersections between each of them where there's a number of activities that are addressing two of the pillars, for example, society and the environment. And many of these activities either need to involve or are led by engineers. And certainly in most cases, they require engineering input. So we need to be engaged in all of these pillars in varying ways. I would have to say that for all of these pillars, these considerations creep into most of our disciplines and areas of practice of engineering. For example, take the example of consumption and production, which is one of the UN Sustainable Development Goals set for our world. Engineers and engineering are both consumers and producers. We consume resources to achieve engineering work, so it is a sustainable practice to minimize, reuse, or repurpose, amongst a number of other strategies, of our limited, non-renewable, and renewable resources, and consider their use over long periods of time. Next slide. The other factor that's creeped in, particularly in the last, say, 20 years, and particularly is very, very topical today, is climate change. And of course, that's all over the media, and we're seeing the effects through extreme weather events and so forth. You cannot consider sustainability, which is a long-term process, without considering climate change. And so it adds an additional layer of complexity to achieving sustainability. Our climate has become non-stationary, meaning that it is changing and the rate and degree of change remains uncertain. Consideration of climate is over the long term, so climate must be considered in the long life cycle of infrastructure and its supporting systems, for example, that will operate in a changing climate. The long-term trends in climate introduces another element into the design and operation of engineering works. So we need to always consider going forward, now and going forward, climate change, both in and of itself to reduce the rate and degree of climate change, but also incorporating into our products and services and engineering works. So this relates to things like reducing greenhouse gas emissions, energy use, and so forth, as well as building climate resilient buildings and so forth. Go ahead, next one. So this has been, the whole notion of sustainability has been recognized internationally for quite almost 20 years. And here's a statement by Engineers New Zealand that kind of is I guess a statement of the imperative. I'm not going to read it out to you, but just to say that this kind of imperative has broadened to the world, in the sense that we have the UN Sustainable Development Goals. So the idea here is that, we need to work out strategies and processes and so forth to address sustainability. Next one. I just keep pressing it until it comes out there, because it's okay, here we are. So just briefly to touch on the Sustainable Development Goals, because they drive the world's response and the strategies around making our world sustainable. You can see there's 17 goals. that are listed here. Many of those goals require engineering and engineers to be involved, either in supporting or leading roles. Working on these goals has become a focus of our World Federation of Engineering Organizations, which comprises over 100 national engineering bodies, including Engineers Canada, to work on these goals around the world and get engineering involved. It's become part of their strategic plan and part of their strategy over the next, it's now about halfway through. They started in 2015 and goes till 2030. Next one. So just to talk a little bit, just to set up the whole notion, we're talking also about environmental stewardship as part of sustainable development. We certainly, as engineers, we get involved in the projects to design and build things to meet basic needs, and also on the environmental side to address and solve environmental problems. The engineering profession is generally neutral about this in the sense that they provide guidance and advocate for informed decision making, but engineering projects are not neutral because they affect the environment, the economy, and people. So engineers can influence through their leadership broad and long-term outcomes, be pressured to consider short-term cost-cutting measures. That's certainly a reality that many of us face as engineers in our practice. And another aspect is to undertake value engineering to improve products and processes by considering their function and cost. These are all opportunities to pursue sustainable development through more efficient use of resources and the production of better goods and services. Next one. So one of the dilemmas we have as engineers is often we're not the decision maker. We're subject to direction from clients or from project sponsors, that sort of thing. So we have to make some demand. There are some demands on us. Recognizing the needs of local communities. We're required to provide good information to the decision makers so they can make informed decisions. And of course, it's an opportunity to assume leadership roles. And in some cases, the engineer may have significant support in pursuing sustainable development and environmental stewardship. But in others, the best that could be achieved is improving the outcome of what might otherwise have occurred without their input. In either case, the engineer has the potential to contribute positively to the future and can do so by providing leadership within their area of practice. Next one. So we have in Canada, through Engineers Canada, a national guideline that's known as the Principles of Sustainable Development and Environmental Stewardship. So this is guidance from the profession, and it's was issued by Engineers Canada a few years ago. This guideline is on the PEO website and several of the other regulators across the country. And it establishes 10 principles that engineers can follow. So it's not just, this is kind of a concept, but here's how you can incorporate it into your practice. And so it provides both guidance and commentary on that. So the principles, if you can just click it the next time here. Yeah, so the 10 here are listed. I'm not going to go through all of them, but I'm going to go through a few examples of a few of them that are related more to sustainability, and some of them are more environmentally focused. So we'll go to the next slide. So we'll just talk about the social impacts. So we want to make sure that we're always mindful of the public good, and we have to think about not just the present or locally, but for the future, and think about the implications beyond the limits of the project. But they certainly, we have to be mindful also of the social impacts and benefits that a project gives to the community, and that influences then our actions. And that involves in providing positive and negative effects, getting an understanding of the societal values of the area where the project is being undertaken, and to look at, not just sort of the quick fix, but, how do we go beyond the just thinking about the most quickest and one might say dirtiest solution. And I think you also always have to kind of be, reviewing and being critical of solutions being presented and also evaluating the needs. Are they needs or are they wants? Next one. Of course, it's always projects are driven by costing and economics. Benefit cost studies are often part of that, evaluating the economic viability of the project, and that can be not just a project but a product that engineers work on. So of course there's all those categories of costs, and one must think about the whole life cycle of the project or the product, including things like decommissioning or deconstructing, and what are those impacts on the social and environmental costs and benefits. Obviously, you want to look at life cycles, want to look at the true costs, and in certain cases, now with GHG, monitoring GHG emissions and the reduction of those emissions. And so we need to think of those aspects, when it comes to costing economics. Next one. I think a really important element of engineers' practice is innovation. That's part of our job, is to come up with innovative solutions to problems, that we are problem solvers. And we have to do this in the I guess the context of limited resources, and also to balance those pillars of sustainability. So it's a combination of, what is most important. Hopefully you have a balance and you meet all of those pillars, but sometimes things get prioritized. Obviously, economic being one of the big ones, but you always want to be mindful and present cases for the environmental and the social impacts. And I think that's a really key thing for engineers as leadership, is to be that voice for those considerations. And there's always opportunities here for innovation. And I think you'll find some examples in the following presentations around innovation. So next one. The other one that I obviously have spent a lot of time in is risk mitigation, especially in light of climate change. Again, the uncertainty of climate change, you need to find ways to define and manage risk and do risk reduction measures. There's also the element of not knowing all the science or the uncertainty, and so there's a concept called the precautionary principle of acting before perhaps you have all of the information. So don't analyze it to death, but that's where your professional judgment comes in. You say, I've got enough information to make a call on this, and of course you need to have sufficient information, but you may not have complete information in a lot of cases, but you still need to act because of timing, schedules, budgets, and so forth. Next one. So I think if you kind of do this more broadly, we've thought a lot of the linear economy, where you start off, say in mining, you start off with extraction, you transform the minerals into a product, it's consumed, and then it's whatever that product or service is, it's disposed. Next one. Then we go to the whole notion of what we call the circular economy, and people have certainly heard about that. And it's really strategies like reusing and repairs, remachining, recycling, composting, and as an example. There's actually 7 R's to the whole notion of a circular economy. Again, I'm not going to go through those, and if people are interested, I can rattle off those terms later on. But there's a lot of ways that you can achieve a circular economy, and engineers should start thinking that way. It's not just one linear path. It's really finding ways to reuse and repurpose, for example. Next one. There's a lot of sustainability hierarchies in terms of best use and worst case kind of thing. You can see here, the right side is an energy hierarchy, starting off with reduce your energy consumption as a first strategy, and then deal with efficiency and all the other steps that you see there. And then there's the whole notion of the R's, the reduce and conserve, reuse, recycle, regulate, and all of these provide less value the more that you get lower in the diagram there. So next one. And I'm not going to again go through this in any detail other than to say you can study it later because these presentations will be available, but you can see certain actions that principles and actions that can be assigned to different pillars of sustainability. And these are, I think, give you again some guidance in your practice along with the guideline that I've briefly reviewed here. Next one. And I think the bottom line of all this is that, you know, we need to lead the way and be seen to lead the way towards a more sustainable future. We're in a great position to do that by the work that we do, the way we think, the clients and people we serve. So I would encourage all of you to embrace this concept and the principles behind it. Look at it, of course, for your projects or for your product, but think about it in terms of, you know, we're trying to extend the resources we have available and as much as possible reuse and repurpose what we have. There are certainly challenges, you know, a lot of clients, and there is a cost associated with it, but I think in some cases one can make the business case. A great example I know of is actually Denis sent me just recently the cost of deconstructing a house versus putting all the you know, instead of knocking down the house and putting it into landfill. And if you were to deconstruct the house and sell the materials for other housing, they actually, in this particular study, showed that you could make money on it, and it reduced the costs anywhere from 2 to 10% of the house that was using those materials. So I think there are lots of ways of innovating and can be overcome. And, you know, that's in our DNA. We are problem solvers, and this is a problem to be incorporated into our practice. Next one. I think that's it, but just be sure. Yeah, here is a listing of resources. So that Marilyn Spink compiled in another presentation, and I've added a couple more to it. Two, I'd just like to point out briefly for people to have a look at. One of the most recent publications on this is by a fellow by the name of Gavin, Updated Principles of Sustainable Engineering. That's a pretty recent publication, and there's a lot of good stuff and thinking in that. And I just learned the last couple of weeks that the American Society of Civil Engineers has released a sustainability standard. And there's a link there that you can all go and have a look there. So you know, that's a way to start your journey is looking at some of this material as well as reviewing the guideline. And I will pass it back to the presenter for the next presenter. And I think I went a bit over, and I'm sorry, but I had to try to cover it off. So thank you.
All right, thank you, David. I'd like to introduce Dr. Denis Isabel, Sustainability Vice President for M.A.Sc Lithium. Dr. Isabel holds a B.Sc in Geology and B.Sc.A. in Engineering Geology from Laval University, as well as a M.Sc and a Ph.D. in Water Science from the National Research Institute. He is also a Fellow of Engineers Canada. His work experience ranges from university teaching and research to mine environment, consulting, and mining operations management. He is a senior environmental engineer and hydrogeologist with more than 40 years of experience in applied environmental engineering in the mining industry and in team management. Experienced in tailings and waste rock management, mine water management and treatment, environmental impact assessment, and permitting and mine closure. This evolved into management and executive positions and developed solid experience in workplace health and safety, and people management, financial management, and strategic planning. He also has developed hands-on experience in community development in developing countries and in sustainability principles implementation. Welcome, Dr. Isabel.
Thank you very much. So I will share my presentation. Give me just 1 second. Sorry. Okay, can everyone see it?
Yep.
Okay, so thank you. So something was missing in my presentation is the fact that I don't really speak English. So bear with me if sometimes it's a little bit bumpy, but I will try to do my best. So first of all, some years ago, I was involved in the development of that guideline as a member of the Environment Committee of Engineers Canada. So I know of that guideline, of course. So I keep it with me over my career after that point on, and I will show how. But what I will do is that I will take 3 of the guidelines included in the sub guidelines and show you from example that I take from my own company that I work with after doing with you a small introduction of M.A.Sc lithium. So is it nice? That's our body, all white. Okay, M.A.Sc lithium project is an integrated project. The word integrated is important because there is a mine in Iuichi region, northern Quebec, commonly called James Bay area, and this is the Wabushi mine, where we mine a rock and produce a concentrate of a mineral called spodumene that contains the lithium. It is then transported by truck and rail to Bécancour in southern Quebec, where we are building a plant to transform it in lithium hydroxide. That, you know, in Canada, it's been a long time that we have mined, and quite often we mine and we sell the concentrate outside of Canada. And it's more and more common that we don't do all the value chain of the transformation of that material. So we lost economic value, we lost a lot of things, and are always also losing possibility for circularity and sustainable development doing so. That's why we are really proud to be an integrated project doing the first transformation in Quebec. And other companies are building plants just beside our own plant to do the next step in the transformation to go to the battery. So we have a 33 years mine, which is quite long in terms of for a mine. So usually the life of mine is shorter. And that's a very small mine. We are producing at the end, after transformation in Bécancour, only 32,000 tons per year of lithium hydroxide. Because we are in Quebec, because we use energy from hydroelectricity as much as possible, not completely, but as much as possible in the process at the mine and at the process plant. We are able to produce lithium hydroxide with a carbon footprint as low as the lithium coming from brine in South America, where they use the sun for direct evaporation and concentration. So usually they are producing the lithium with the lowest carbon footprint, but because of the situation with hydroelectricity in Quebec, we can compete with them on that carbon emission. So a few pictures of the mine on the left. So that's under construction, and on the right, the transformation plant with the drawings. Of course, that slide that from last year, I will have picture of the actual construction later on. So one of the first guidelines from the Engineers Canada guideline that I want to speak to you about is considering social impact. That mine is located on Cree Nation of M.A.Sc territory in Iuichi. Iuichi in Cree main territory of the Inuit or Cree. They call themselves EU. So we are on their territory, and we have an agreement with them. And the gentleman you see on the picture is the tallyman. So we are building the mine on the territory used by him and his family for fishing and hunting since many generations. So for us, Mr. Wapachi is a very important person, and he helped us taking care of the land. We have with that community an agreement, a contractual agreement with the Cree Nation of Nemaska, but also with the Cree regional government. Maybe you know, but in that area of northern Quebec, that's one of the few places in Canada where there is a recent or decent territorial agreement that supersede the previous treaties and that give rights and due and rules the occupation of the land, and that's why we have certain duty and report to give to the community when we use the land. And in that benefit agreement, we are sharing part of the benefit of the operation of the mine and the process plan in Bécancour with the community of Nemaska village. We have the same name as the village, as the community, and we ask again and again, many times, do you consider it as cultural appropriation? And they always say no. So, and in fact, I think that they are happy that we are bringing the name of Nemaska outside of the area, and that put them on the map, if I can say. So in that agreement, there is a lot of things going on, and a lot of commitment and objective in terms of economic, employment, good care of the environment, and reclamation of the mine at the end, and all that is all embedded in the agreement. And it goes with a series of committee and that meet on a regular basis to make sure that we walk the talk, so that the agreement is really implemented. So there is the main committee, the WIC committee, Wabushi Implementation Committee. So the name you see on that committee are a board member, a management member, and on our side and on the Cree side are member of the Cree on the Band Council, for example, or the Local Economic Development Board. And then we have a series of committee, 3 main committee, the Environment Committee, where we report everything. All the permit requests we submit to the committee before. All the consultation for any modification of what's happening in the mine, we submit to the committee. And each year we submit the complete report of all the monitoring to the committee. There is an Economic Development Committee where we develop ways to increase economic fallout on the community from the mine operation and construction. Up to now, it's working well. Most of the contract many contracts have been given to community business, like the camp catering, the field, the earthwork construction around the mine, building of roads and excavation of water reservoir and a lot of things. And also we are working that even smaller thing like snow removal, of course, is done by them. And we are going to discuss for them to carry the concentrate and to even go further into providing service.
না এটা তো একটা ওয়েবিনারও আছে, এবারে দিয়ে কাজও করি সব।
Sorry, are you listening to me? Hello.
I think keep going,
Yes,
Denis.
we can hear you.
Okay, because I heard someone speaking, so I was thinking there was a problem. Sorry. So there is also the Training and Employment Committee. The objective is obvious. And also most of the smaller committee is a coordination committee. But all those other committees are meeting quarterly. But the coordination committee meet every 2 weeks. So that means we are in continuous discussion with the community. So anything that is discussed in those committees is under preparation by the coordination committee, and all the action and the decision taken in all those committees are implemented through the coordination committee. So this one is is where the work is done. Okay. once the decisions are made. So that's how we are making sure that we are well involved with the community, and that we, as I said before, we have an agreement, but it needs to be implemented. That's the tool we are using. When I'm working in that, I'm an engineer. I'm not a social guy, but I like to tell that when I was a young student doing differential equation, I was looking at my friend in the so-called soft science, drinking coffee and other liquids. And I was thinking myself of being very better than them. And now the skills they were working on is the skills that I am missing now to do all that political and community and sociological and ethnological work. So the learning curve was steep, I can tell you. So just to show how community engagement and for that part of the guideline can go very far. For example, this summer, you know, there was forest fire in the area. All the elder of the community had to be evacuated because there was too much smoke. So they were evacuated to Quebec City. So we welcomed them in Quebec City, and while they were staying in 2 hotels, we organized a series of activities for them. And we make sure that the local First Nation of Wendat, they cook First Nation meals that we bring to them. So I think that they enjoyed their short vacation in Quebec City. Also, we are another thing that we did, and we are repeating every year, is that every year we organize on site in the village an environmental and earth conference. Of course, we use that conference to present our result of the environmental monitoring and activities, but also we invite all the researchers from universities and research centers that are doing fauna, water quality, or whatever, even sociological research in the area to come and present their research and results. And that is very, very popular, because that event, in a population of 800 people, we attracted 200 participants. So a significant percentage of the population of the community is participating in that event. And of course, we are not doing that all by ourselves. We are consultants that help us, called name Transfer Environnement and Société. And all those events were also organized with the help of the Cree Nation and the regional government of the Cree Nation. We are also supporting some research program around, one with the University of Sherbrooke about using a native plant for mine site rehabilitation that will be used in our rehabilitation of the mine. And we are also working on another research on the biodiversity around the mine site. And we are also working with the INRS to do the monitoring of the type of fish in the lakes and river around the mine using DNA tracking in the water. And also, it's not in that slide, but we also just started a new project with another university in UQAT, Université du Québec en Abitibi-Témiscamingue. That's a research about the entrepreneurship with Cree women. So that's for Guideline 3. Guideline 4, designing and evaluating sustainability outcome and environmental stewardship indicator. There exists a series of standards or indicators for ESG or sustainability. Some are very formal, some are in the form of standard that you can be audited, or they can be evaluated and giving a rating. There is one existing for the mining industry, and that's what I want to present to you, because I know it very well. all the mines in Canada are using it, and it's now spreading around the world. So this is the TSM system, towards sustainability in mining. Okay, and sometime when we speak with some environmental people or activists about mining and sustainability, they see this as two words that cannot stand in the same sentence, because mining is if we are working with non-renewable resources, and so in their mind that does not fit with the word sustainability. But I will show you that it can happen. So mining is essential first. For the society to be sustainable, we need the mining. The future need the mining, especially with all new materials required for the new economy. And it can be done in a responsible way and with the community, as I showed when my discussion about the guideline number 3. So there is a system of evaluation of the sustainability part of the management of a mine that exists in Canada. It's been implemented and developed the Mining Association of Canada, and that's a system that is gaining attraction. It is almost used by all the mine in Canada, as I told you. It is transparent. You can go on the website of the Mining Association of Canada and get all the information and get all the results from all the mines that are registered to that system. It is credible, it is accountable, and it is measurable. It gives you a grade. So we can see how well the mines are measuring to each of the protocol that compose that standard. So it is composed of a series of standards that is a list of requirements on many aspects: indigenous and community relation, tailing management, for example. We have the list here on the slide. And for each of those protocol or substandards, there is objective to be attained, and you get a grade depending on how many and how much of those objectives you have reached. And then you can get a grade A or grade AA or a grade triple A. And if you're not there at all, you get a grade B. And if you're just thinking of registering and starting the process, you get the grade C. So, and you get a grade like that for each of the 9 protocol. It's evolving. When it started a few years ago, there were 7 protocols, and now there is 2 new ones being added, and they keep being revised and upgraded each 2 or 3 years. And a mine that go through that system get a grade for each of the protocol, and the final grade for the mine is the lowest grade that they get for any of the 9 protocol. So that's really an incentive to improve your efficiency in terms of sustainability. So the 9 protocols are there, and those are, as I just said, upgraded every 3 to 5 years about, and also they are audited, okay, by external auditor. So that's a program that is, I think, very, very valuable. It is now recognized by many funding organizations, like big investment funds. They use that to check if they are investing their money in mining that company that are well managed in terms of sustainable development. And also it started being implemented around the world. It started in Canada, but now it's now implemented in many other countries, and it keeps increasing. There is discussion with other countries as we go to spread that system around the world. And it all started from Canada. It is also overseen. So there is, it's been developed by the Mining Association of Canada, but there is a structure about that, okay? So there is a community of interest advisory panel. that is composed of representatives from the society and from the environmental NGOs and First Nation and all the other people outside of the mining world. And then we have a board of directors, a governance team, some initiative leaders. That's when we start or upgrade one of the protocol. There is an initiative leader team that is built to do that. And it's all reviewed by subject matter expert committees. And that's how we keep improving the system each year and being validated by the external community of interest panel, advisory panel. So that's it for guideline 4. The other guideline I want to speak to you about is guideline 8, always with an example from M.A.Sc Lithium, leading, communicating, and consulting. I told you that we are building a plant in southern Quebec, and even if it is physically a large plant, it is only producing 33,000 tons of lithium hydroxide per year. And in terms of local regulation in Quebec, that is too low to trigger the impact assessment study regulation and to require public hearings. But to make sure that our project is well accepted by the population and to make sure that we listen to their concern according to that guideline for sustainable development and engineer, we elected to do voluntary an impact assessment study, complete impact assessment study that was not required by regulation or by law, but we did it. And that picture is showing you where it's the industrial park of Bécancour in southern Quebec, and the red handwritten square is our property where we are building that plant. Just for your information, GM is building a plant beside us, and Ford is building a plant in front of us on the other side of the highway. So a few pictures of the plant, always nice when it's a model picture. So why we did that impact assessment study? First is to support our permitting process, for example, even though it's not required. When you request a permit and you did all the evaluation of all the impact of your project, is more easy to explain to the environment regulator how you proceed to manage those impacts and have an acceptable project. It's also a good tool to have a good acceptance of the project in the area, because building a large plant like that, and that plant is having impact. We are not hiding the impact. In fact, we are showing them completely, transparently to the population. And we did that at the same time we were doing the feasibility study, so that information collected during the study about the impact and mitigation measure discussed, we were able to implement many of them in the design of the project. Also, there was concern from the population, and obviously and curiously, the concern were not always biophysical concern. There was many social and economic concern about the project. For example, if in the impact assessment study, when we were asking in focus group and questionnaire with the population, with the normal people living in the area, what are their biggest concern with the construction of that plant? And then we take all the answer and put that in a ranking. The one that get the more attention was lack of place in the kindergarten for the kids, because new work, that means that there is already a problem in the area, and bringing a plant with new workers will just increase the problem for them. So it's very interesting doing that impact assessment study because it's not what we think as engineers that are the impact, that are the real impact from the population point of view. Also, that plant is in the area that is on the traditional territory of another First Nation that are the Wabanaki, and they have a reservation not far from the plant. And so situation is different in the southern Quebec. They don't have a territorial agreement at all, and they have all their previous land is now almost all owned by private people all around. So despite that, we work with them. In fact, a large part of in fact, the total chapter on project impact on First Nation rights has been written by the First Nation. So we pay them to write that part of the impact assessment study. And we are now working with them to develop not a benefit agreement, but a cooperation agreement, we call it, which is also a way that we can use money from the project to help them do some cultural development and help save their culture and their link to what remains of their land. And for all the population, First Nation and others around, we did a lot of meetings, consultation, and direct consultation with all the stakeholders, the NGOs, the Chambre de Commerce, and the association, schools, all that. A full impact assessment study, but at the same time, that was our way to implement our project within that the area as a group. And I'm going faster, and this is the extract from our impact assessment study and the chapter on the sorry for the French in some document. The impact of the project on the right of the Wabanaki Nation. And we use also an online consultation platform because some people don't like to come to public meeting and speak freely, but we open on the social media a consultation platform so people can go there and ask their question, put their commentaries. We also develop a local purchasing policy that we share with all the economic organization around, and they agree with. So we are using it in the procurement, and now we are building the plan. So that's the picture from 2 weeks ago. The construction started this summer. So that's how we implement the consultation that we are doing with to make sure that we take into account the opinion of the population where we build the project according to that guideline of the Engineers Canada Sustainable Development Guideline. Two last thing I want to tell you about that project is that when we were still doing the pre-feasibility project with our consulting partner, which is Hatch, I asked that all the engineers working on the project be given a copy of the guideline. And then I asked Hatch with their Sustainable Development Department to organize a training, half-day training on the guideline and sustainability for all those engineers. And then we did in small group 1 day workshops about how they think they can implement the guideline in the design of the plant. And a lot of things came out of that. And I think the best thing of all is that they rethink completely the water circuit, the management of water in the plant. And now we are building a chemical plant with zero liquid discharge, zero processed water discharge. Everything is in terms of water. So we are saving water, we are saving the cost of the water treatment unit, and we are saving the impact of the effluent of a chemical plant on the environment. So, and there is other things that were implemented in like energy recovery at many places and so on. Last thing about that project that goes with sustainable development is that small graph show you that there is a plant that is producing a product at 32,000 tons per year, as I told you before, but that process is also producing residue or byproduct, depending what you want to do with it. And there is aluminosilicate, gypsum, and sodium sulfate. And if you do the math, you'll see that we will be producing 10 times more residue or byproduct than product. So recycling or valorization or use of those byproducts by other industry is very important in the project. Because if we don't do that, if we don't exert a good circular economy with other industries, we will fill all the landfill of southern Quebec in a matter of a few years. So that part of the project is almost as important as producing the product by itself. So we are now devoting a lot of effort working with a series of industries that will use our byproduct as their product to produce other things. So the aluminosilicate can be used for Portland cement, concrete, ceramic, glass, gypsum, Portland cement again, building materials, and compost mix. And sodium sulfate used in powder detergent, potassium sulfate, that is a nutrient for the plants, and sulfuric acid and sodic costa. And that last one is very interesting because if we can do it at high concentration, that means that we can use that sulfuric acid and sodic costa to replace sulfuric acid and sodic costa, caustic soda that we are already purchasing to operate the plant. That will be the full circle if we can do it at high concentration. So that's the end of my presentation on the example I can give you on 3 of the guidelines of the Engineers Canada guideline. Thank you for your attention.
Thank you very much, Doctor. Good evening. My name is Isabel. I'm here to introduce Dr. Peter Frise. He holds degrees in mechanical engineering from Queen's and Carleton universities and has worked in the tool, die, and mold industries. He founded Canada's first university program in automotive engineering in 1998 at Windsor, while serving as Chrysler Canada NSERC Senior Industrial Research Chair in Mechanical Design. In 2000, he was elected by a Pan-Canadian Industrial Academic Group to lead the new National Automotive R&D program called Auto 21. Dr. Frise has served on numerous boards and committees, including the National Research Council of Canada and the Professional Engineers of Ontario. He has been also a member of the Complaints Committee of PEO for more than 26 years and has chaired the group since 2020. Peter was elected a Fellow of the Canadian Academy of Engineering in 2000. In 2012, he received the Queen Elizabeth II Diamond Jubilee Medal for his service to Canada's manufacturing industry. Without further ado, Dr. Peter Frise.
Thank you very much, Spiro. It's actually Frise, but that's okay. I want to thank David Lapp very much for this kind invitation to take part in this very, very interesting seminar. I want to thank Amanda, Jim, Luis, and Cristy as well. And to Denis, I just want to say, votre anglais, c'est très supérieur de mon français. Bravo. Okay, let's see if I can share a screen with you. Boy, oh boy, here we go. There we are. Okay, can everybody see my slide? Can somebody say yes or no?
Nope. Nope.
You cannot. Damn.
Not
Okay.
at the moment.
Hold on. Shoot. Well, I'm trying to share. That one. Oh boy.
Oh, it looks like it's starting.
Okay. Can you see it now?
Yes,
Yes.
to listen.
Yes.
Okay. Can you? Okay, I want to put it on slideshow. Can you still see it?
Yes.
Yes.
Yeah.
Now we can
Okay,
see the
great.
icon.
Okay, very good. Okay, so my talk is gonna be different from Denis, because the auto industry is kind of at the beginning of its drive towards true sustainability through electric mobility and other technological developments. And so there's lots and lots of issues and problems, but only some answers. We really cannot emulate the excellent work that Denis' company is doing in Quebec, both at the mines and at the refining center in Besançon. It's really impressive, Denis. I'm really quite inspired by what you said. Anyway, off we go. So it's a big world out there, and it's been my experience that almost everybody who has a driver's license thinks they're an expert in the auto industry, and they think that all the auto companies are stupid and they just don't build the right cars, and that's why nobody likes the cars that they're building. Well, the fact of the matter is that the auto industry has to respond to basically three vectors of pressure. Industry imperatives, and you can see them there. They have to produce high quality parts at the lowest possible cost, very capital intensive. It costs billions of dollars, billions with a B dollars, to make or to develop just one new model of a car. It's quite variable. It depends on how much prior technology is being adapted. But of course, when we're moving from IC engine vehicles to electric vehicles, you know, I mean, the degree of adaptation or adoption of previous technology is not very high, so a lot of things have to be developed brand new. They also have to respond to government demands for energy security, environmental safety improvements, environmental performance, and of course, good jobs. That's why everybody wants an auto industry, because it's a huge producer of high quality jobs. And it's simple economics. If you think about it, the two most expensive things that most people buy in their life are a house and a car. When you buy a house, most of the money for the house that you paid for it stays more or less where the house is, because that's where the labor came from. House materials don't tend to be shipped very far. So a lot of the wealth stays in your local community. But when you buy a car, most of the money gets shipped back to where the cars are made. And of course, I live in Windsor, Ontario, so I'm fine with that. And of course, the car companies have to respond to consumer desires. And basically, at the root of it, what the consumer wants is a better value proposition. And the value proposition for any product is basically the quotient of performance divided by price. And the interesting thing is you can define performance in a lot of different ways. It can be, you know, how fast the car can go, how quickly it can go around a corner, fuel economy or energy economy, durability, fun to drive, cool features, and so on. You divide that by the price and you have the value proposition. You know, if you have 4 kids, a 2-seat Ferrari isn't a good value proposition for you. So different strokes for different folks, if you like. Okay, so really what this boils down to is that designing a car is an extremely complicated and difficult balance among a whole bunch of competing factors and priorities. And I won't read them to you, but you can see in that list energy, environment, safety, which are government mandates, performance and handling, which are consumer desires, acoustic performance, all those other things. And then they have to make money doing it, so it has to be manufacturable at a reasonable cost. The car has to be serviceable or will develop a poor reputation in the market, and so on and so forth. So it's a very, very complicated business. The auto industry is, we always say it's not for boys and girls, it's for women and men. It's lots of fun, but it moves very fast, and the consequences of a mistake are brutal. Nobody has $1 million problem. They tend to have $100 million problems and $1 billion problems. So let's look at some progress here. If you go back about 30 or 35 years to 1988, you will find the Ford Escort, which I owned a Ford Escort. It was a pretty good little car. And I drove the hell out of that thing. And it was a good car. And then its nearest sort of counterpart today would be, let's say, the Ford Focus. But you could put in a Toyota Corolla or a Nissan Sentra or a Chev Cavalier or whatever you like. But look at the difference in weight. The new car is 42% heavier, but it has a 0 to 60 time of half. So the car is much, much quicker and faster, much more powerful. And it gets, almost 50% better fuel economy if these are internal combustion engine vehicles. Plus, it has all those features, fuel injection, ABS brakes, all those things that you couldn't get in 1988. And it actually costs less today or in 2018 than the Escort did. How the heck do they do that? Well, that's how. Engineering. That's our accomplishment. It's a very, very, very competitive industry, and they've made the industry, and I don't work for any of the car companies, I really don't, but I will tell you that they have made tremendous progress over the years at making new vehicles much safer, much better performing, and much more energy efficient than their predecessors. However, that's not enough. And so let's look at various aspects of the modern vehicle. Let's look at materials and body structures. And the old saying is, if you look after the ounces and grams, the pounds and kilograms will look after themselves. Okay, so this is a very nice car. This is a Jaguar F-type car. And I just wanted to show you some of the things that car manufacturers are doing to reduce weight. I mean, you have the big things like building the body out of aluminum, which is much, much lighter than steel, and so on. But there's even little things. The windshield, the windscreen in this car, the windshield weighs 2 kilograms less than a conventional windshield of that size because it is thinner. The carpets, the interior carpets, weigh 15 kilograms less. All of this translates to much better on-road performance, but from an environmental standpoint, much lower fuel consumption. And so these are the kinds of things that people are working on every day in the auto industry. And so in the auto industry, there's really two big drivers that the average parts company engineer has to look after, and they are cost and weight. And they're constantly battling cost and weight. Okay. Now, when we start talking about electric cars, it really is all about the battery. Vehicle weight is a very important factor in on-road performance and so on. But it's more than just the vehicle weight. There's a phenomenon called mass compounding. So basically, this is a page out of a recent issue of Automotive News just a few weeks ago. And if you look at it, just look at the caption up top. It's a vicious cycle. If you, I can't get rid of that banner that's over top of the darn thing. Whoops, sorry. If you have a 6,000-pound vehicle versus a 4,000-pound vehicle, you need bigger brake rotors, bigger calipers, heavier springs, larger wheels and tires, and so on. So weight begets weight. If you add weight, in the form of a big battery to drive an electric vehicle, you need bigger tires, suspension, heavier body structure, and so on. And that is weight compounding. Now, how much weight are we talking about? Well, if you look at, a new model, 2020, what the heck is that? 2024 GMC Hummer EV Omega Edition, the battery alone weighs 2,818 pounds. I'm sorry, I don't have that in kilograms, but it would be probably at least 1,200 kilograms, maybe more. And so to give you an idea, the battery for that pickup truck weighs as much as an entire Mazda Miata. And that's the kind of weight penalty that electric vehicles play, and it's a big deal. So what that means is that some of these big SUVs weigh upwards of 9,000 pounds, which is, you know, beginning to get close to what a commercial vehicle weighs. And this is a big deal. So if you look at what the weight of some of these modern electric vehicles, an Audi Q4 e-tron, which is, you know, a mid-sized vehicle, weighs over 4,600 pounds. A BMW i4, which is a relatively small car, weighs over 4,600 pounds. And remember, a 1988 Ford Escort weighed less than half, or about half that, 2,400 pounds, and even a 2018 excuse me, Ford Focus weighed about 3,500 pounds. So electric vehicles are heavy, and it's because of the battery and the attendant mass compounding that goes along with that. So, you know, another issue that this impinges on is even something like tire wear. And there's a story in this, I just clipped this out of Automotive News. There's a story about a guy in Colorado who had a Rivian, which is a new model electric pickup truck. He loaded his truck with 2 motorcycles and hit the road. About 6,000 miles later, nearly 1/10 of an inch of rubber had worn off his front tires. And that rubber is all out there in the environment in the form of little microscopic particles. And, you know, those are possibly toxic to wildlife, not good for human beings. They cause air pollution and so on and so forth. So there's a lot going on in the average car, and the heavier they get, the worse these problems become. The other issue with heavy vehicles, and I keep emphasizing weight because electric vehicles with present battery technology are going to be heavy, is they pose a serious risk to all road users because of the amount of kinetic energy that has to be dissipated in a crash. As I say, they weigh up, these big electric pickup trucks people are buying now weigh up to 9,000 pounds, but they're driven and often maintained by rank amateurs. You know, these are very large, heavy vehicles with an awful lot of kinetic energy on board and a lot of chemical potential energy. And if you want to find out about that, just type EV battery fires into your Google search engine and watch some of the YouTube videos that come up. These vehicles are extraordinarily difficult to control once they start to burn. So this is a crash test of a Rivian, and you can see the damage. This is called an offset barrier crash test, where the front of the barrier that the vehicle hits only begins halfway across the vehicle. So it would be like if you kind of sideswiped a retaining wall or a bridge abutment or something like that. And there's some statistics here, and you could look at them later, that show how the number of fatalities is going up as the number of heavy vehicles on the roads go up. And I'm not suggesting that all of this is due to EVs, but it does point out to you the impact of heavier vehicles on road safety, and there's no question that it is a concern. Okay, let's talk about powertrains. It's all about the powertrain. That's what people really want to buy. Okay, this chart comes from Ricardo Engineering, which is a top-notch powertrain engineering consulting firm. They're actually based in the UK, but they have offices all over the world. And now, don't worry too much about the units for that scale on the left. It's energy density, which is kilowatt hours per kilogram. And this data is getting a little dated now. I think it goes back about 4 or 5 years. But you can see at the top that diesel, kerosene, gasoline typically has 12 kilowatt hours per kilogram energy density, and ethanol is significantly lower. So if you know somebody who's got a car that runs on ethanol, for instance, they'll find that their defroster doesn't work very well in the wintertime, and they have to fill the fuel tank more often than a comparable vehicle with gasoline or diesel. Well, the reason is because ethanol doesn't have as much energy in it. It's as simple as that. And then you go down, you have CNG, compressed natural gas, hydrogen, and so on. And look at where lithium-ion batteries are. And I'm not anti-EV at all, but this is the reason why the battery in a big pickup truck weighs nearly 3,000 pounds, and a fuel tank in a big pickup truck full of fuel might only weigh 200 or 250 pounds. It's really energy content per kilogram. And unfortunately, with the present chemistry, batteries are way down the list. And so, you know, I make some statements at the right there about the competitiveness of EVs, and I have full confidence that they will get there, but it's going to take an awful lot of R&D. One industry authority said that the present electric vehicles, in terms of their evolution towards full potential, are something like a car was in about 1950. 1950 vehicles, we knew how to build them, we knew how to predict their performance, we knew how to make them, you know, safe and efficient in that day, but they are nowhere near fully evolved the way modern IC engine vehicles are. And electric vehicles, the electric vehicle of today compared to an electric vehicle of 2035 or 2040 is going to be a very, very different kettle of fish. Things are going to change an awful lot over the next 8 or 10 years, but it's going to take a lot of money. Again, billions and billions of dollars to develop a new model vehicle. Even in the old days, now it's much, much more than that. Okay, so when are electric vehicles really going to take over the market? Well, this slide comes from Schaeffler Technologies, which is a leading German manufacturer. If you have anything with a ball or roller bearing in it, probably Schaeffler made the bearing, or they make a bearing that could replace the one you have. They own FAG. They make the bearings for the big wind turbines you see up and down the highways all over the world now. They make bearings for ship propellers and almost all parts of moving vehicles, trains, cars, heavy trucks, bulldozers, everything. So Schaeffler predicts that by 2030, in the world, the global market, about 30% of the vehicles will be pure internal combustion engine vehicles. And about 70% of the vehicles will be at least partially electric powered. Of those, about 30% of the vehicles will be pure battery vehicles. And I think that number is low. I think it's going to be higher in the end in 2030. And about 40% will be hybrid electric vehicles. So what that means is that 70% of the vehicles in 2030 will still have an internal combustion engine, and about 70% of the vehicles will at least be partially electric powered. In the US market, which is presently the largest vehicle market in the world, the numbers are a little bit different from that, but not profoundly different. But you can really see the overweighting of pure IC engine vehicles in the United States. And again, I think some of these figures may be modified in the coming years a little bit, but this trend is probably not too far off. This is another good take on the whole thing. This guy here with the big mustache is Dr. Dieter Zetsche, who's the CEO or chairman of Daimler-Benz AG in Germany. When Daimler and Chrysler merged, Dieter Zetsche was the leader of Daimler Chrysler, and then when Daimler divested of Chrysler, Dieter went back to Mercedes-Benz. And what he says is electric mobility and autonomous vehicles are a bit like a bottle of ketchup. You know something is coming. The question is, when will it arrive? And that's That's a key question. Everybody's still debating that. At the present time, right now, in November 2023, the electric vehicle market is very soft. And I was talking to some OEM people on the weekend, and they were telling me that their factories are either moving very, very slowly or are idle because sales are down. And that's probably got to do with the recession and high interest rates and things like that. But because electric vehicles are so much more expensive than IC engine vehicles, they're very sensitive to monetary pressures like that. And that's something else that the auto industry has to ride over. Okay, let's talk briefly about autonomous cars. And the reason I bring them up is because if we could make vehicles autonomous and truly safe, it would have a huge impact on society. Studies have shown that it would decrease energy consumption of transportation because we could plan routes and plan our cities more efficiently and so on. But it would also have a huge impact on the healthcare budget. It turns out that car crashes are the largest cause of death and injury and hospitalization in almost every country in the world. And if autonomous cars can be made truly safe so that the car crash is a thing of the past, it could have a huge beneficial effect on the healthcare system, longevity of humans, reduction of suffering, and so on. Anyway, let's talk about it. Okay, it turns out that 94% of all crashes are due to driver error or misconduct. I was on the 401 today driving up here from Windsor. When I passed through the Kitchener-Waterloo area, the 401 was snow-covered. There was driving snow in the air, and people were still blasting along at 100 or 110, 120 kilometers an hour. Absolutely insane. These people do not understand friction or dynamics or anything at all. And man, I saw some things that really made my eyes water. So, you know, we see it every day in our driving that a lot of drivers are really crazy, and that's a scary thing. Now, this is a very interesting chart, and I'm going to spend just a moment on it. This is the SAE, Society of Automotive Engineers, levels of autonomous vehicle capability. And they range from 0, which is, you know, basically like a 1965 Mustang. It has only a human being. The vehicle can't do anything on its own. The human being has full control over steering, brakes, and speed. And the vehicle does not provide any assistance or guidance or suggestions at all. A modern vehicle would be a level 1. Some functions can be done automatically by the vehicle, like, say, cruise control. So you can set the vehicle to go 100 kilometers an hour, and if you point it at a wall, it will drive into the wall at 100 kilometers an hour. So that's kind of dumb, but that's what a level 1 vehicle is. A level 2 vehicle is more sophisticated, and I would say that most vehicles for sale today are at least level 2, where 2 functions are automated. They might have lane keeping, and that's typically done with cameras that are in the backside facing frontwards of the rearview mirror, and they almost all have cruise control, and often there's active cruise control, so it can maintain a distance from a vehicle that you're behind. And then we get into partial autonomy, which is level 3. And I'm going to talk about that one a little bit more in just a moment. The car can operate autonomously, but a driver is still required to monitor and take over. Okay, then there's level 4, full autonomy plus a human, where the car can perform all safety critical functions for the entire trip. But if you feel like driving that day, you can grab the steering wheel and drive the car yourself. And then there's level 5, full autonomy, where there's no human interaction. There's no option for a human interaction. The car doesn't have a steering wheel. There's no pedals for the brakes or accelerator. You basically climb in the car, say, take me to Aunt Mary's, and off you go. And that has consequences too. Partial autonomy, I think, is bad. I don't think it should be allowed on the road, because what that basically means is the car can drive itself until it decides that it can't drive itself. And then it's sort of flashes a red light or a buzzer or a message from the vehicle communication system and says, oh, you better take over. I can't handle this right now. And so you look up from your magazine and there's a cement mixer coming at you. So I think level 3 is best kept in the R&D lab. Unfortunately, a couple of manufacturers are marketing level 3 vehicles, and I think it shouldn't be allowed. Level 5 is another interesting one. Let's talk about that. So what makes an autonomous car? It's a huge number of sensors that point in all directions around the car, way more than most people would imagine. There's radar and LiDAR and cameras, and then it all has to be sort of fused. All that incoming data has to be fused in a sensor fusion system, and the amount of software required to do that is absolutely enormous. It is incredibly complicated to make all that happen, and it's very complicated to make it happen in real time on a consumer vehicle. Remember, these vehicles, you can make a lab vehicle that costs millions of dollars. That's interesting, but it's got nothing to do with the consumer marketplace. And then you have, people bolting things on them and painting them and messing around with the wiring in them and all that sort of thing. This is really complicated stuff. Like I can't emphasize enough how hard it is to make this work. And one of the key things is the cameras have to be able to see the edges of the lane that you are in. Well, that's all fine until you're in a place like I was this morning and you're on the 401 and everything is covered with snow. You can't see the lines between the lanes. You can't see the line at the edge of the road. And believe me, a modern autonomous vehicle today could not handle that. And that's why you don't see them on the roads now. Okay, so let's talk about level 5. You're riding along in your autonomous car, and suddenly the car sees a cat, a human being, and a cliff. Who dies? What would you do? Or rather, what will your car do? If it's a level 5 vehicle, oh, come on. The choices are complex, but they're not yours to make in a level 5 connected or autonomous vehicle. You are depending on the morals, the level of courage, and the choices made by a software engineer who works for a company that you've probably never heard of. And this is what the auto industry is wrestling with right now. Should we kill the cat? Should we kill the person? Or should we run off a cliff and kill ourselves? Now, you can laugh and say, oh, come on, that would never happen. Oh, yeah, it does. Doesn't happen every day, but it only has to happen once to you for it to make a pretty big impression. If you think about this as you're going home from work tomorrow, think about it. Think about this. And so our friends at Tesla, who build these lovely electric vehicles, have killed a few people. And this one, this article here, talks about a vehicle that Tesla, and the guy was driving it. This is a level 3 vehicle, level 3. And he was driving along, and a big semi-truck pulled out in front of him. And the side of the semi-truck was sort of an off-white color, and it was kind of a cloudy day. And the cameras in the Tesla could not tell the difference between the sky and the side of the truck. And so his vehicle drove under the truck. Now, in a car, this pillar here where my cursor is called the A pillar. It's the pillar that supports the windshield. The pillar that's beside your left shoulder, if you're the driver, is the B pillar. Oh, where's that cursor? This is the B pillar right here. And this is the C pillar. So our friend in this car was sitting in the front seat, literally reading a magazine, when his car went under the truck. And it peeled the roof back from the A pillar to the B pillar, and the whole assembly wound up crunched over the C pillar. And he was sitting in the front seat reading a magazine at the time. If you do the math on that, it's a pretty nasty way to die. So these systems are not foolproof. And in my personal opinion, I think it's very irresponsible for them to be referred to as autopilots. In fact, in Europe, that term is not allowed to be used in connection with any vehicle brand. So where has all of this left the auto industry in 2023, and how could it affect Canada and us here in Ontario, especially from a standpoint of sustainability? Well, here's some points. Future EVs will be very, very complicated with enormous amounts of software, sensors, advanced wiring, including fiber optics. And in my view, that's going to be a major servicing headache. If something goes wrong, it's very unlikely you could fix it at home in your own driveway. It's very unlikely that Joe's garage down at the corner will be able to fix it. It will require a lot of complicated equipment and very advanced know-how. They will have a lot less maintenance. There will be virtually no fluids on the car, except brake fluid and windshield washer antifreeze. There won't be any fuel. There won't be any air filters. And the brakes will last a lot longer due to regenerative braking. They'll only have a simple gearbox, but that simple gearbox is a major source of powertrain noise. Because the electric motor is virtually silent, the gearbox makes it starts to emerge as a big source of noise. It'll have far fewer prime mover moving parts, like literally just a few dozen moving parts, as opposed to hundreds or even thousands. And it will be much heavier than internal combustion engine vehicles, which is a big safety risk. But the future car will still have a body, chassis, wheels, interior, HVAC, setup for climate control, windshield wipers, infotainment systems. It will not fly. It will not have 3 wheels. Those are science fair projects. The future car will kind of look like today's car, but it'll weigh a lot more, be a lot more complicated in some ways, and it will be expensive. I think autonomous vehicles will form a very small part of the road fleet for many years to come. I think many people in industry have told me they don't expect to see a level 4 or level 5 car on the market until after 2030, maybe after 2035. And just because some guy in a lab in Arizona can make it work, that doesn't mean it's going to work in Timmins, Ontario in January. It won't, not with the present technology. Anyway, that's what I have for you. Thank you. I'd be happy to answer any questions. Thanks again to the organizers. So how do I do this now? Stop sharing. There we go. Did it. Good. You're muted.
Yeah, muted. Yes.
There we go. Thank you. Appreciate it. Thank you very much for the fantastic presentation. Tonight, I have the pleasure of introducing Dan Dicaire. And Dan is a professional engineer and certified energy manager working in GHG reduction planning, high performance building development, and sustainability. Over the past 13 years at Ottawa Community Housing, he has coordinated the installation of over 925 kilowatts of solar arrays and managed multi-million-dollar lighting, mechanical, and plumbing retrofits that have saved over $60 million cumulatively. He supported the development of the Ontario's first mixed-use passive house at 1290 Coldray, and is currently part of OCH's development team, which has thousands of high-performance, low-carbon units in planning and construction, including one of Canada's largest passive house building at 811 Gladstone. He led Canada's first net zero panelized deep energy retrofit at 197 Pressland and is now supporting OCH and other housing providers to implement various deep energy retrofit strategies in order to achieve net zero GHG goals. Please join me in welcoming Dan.
Oh, hello everyone. Can we see my screen? Fantastic. All right, so I'm going to get this presentation started. Excellent. So I am thrilled to be. Thank you so much to the organizers, the PO, and thank you to my other colleagues who are presenting. This is a really interesting thing to really see the different facets of how engineers are contributing to sustainability. I'm going to try to give you a little bit of a whirlwind tour of how we can make our housing stock, specifically our existing housing stock, which make up the vast majority of the emissions in terms of our building stock, a little bit more green and a little bit more sustainable. So this is the Presslin Net Zero Deep Energy Retrofit that was completed by Ottawa Community Housing. So just a little bit of background on Ottawa Community Housing. We're Ottawa's largest landlord, about 15,000 units. 100 of those, we've got about 160 communities, 100 about high-rise or mid-rise, and then about 60 townhome communities. The vast majority of our stock is over 50 years old. Over 2/3 is over 50 years old, which means it's kind of at a life cycle tipping point, if you will. And at the same time, because they were built maybe in the 1960s, 1970s, definitely a less stringent energy standard. And so they do consume a great deal of utilities. So we spent about $26 million a year. That was actually in 2022, sorry. But now we look at what does it need to look like in the future. And what I'm showing here is from the City of Ottawa's Climate Change Master Plan, which kind of outlines where we are right now in terms of the emissions for the entire city, and how in 5 different sectors, the city is hoping to really draw down GHG emissions in order to reach the 2040, 2050 goal of net zero within the city. And I'll point you to the bottom green areas, which are the existing buildings, which make up the vast majority. We've got about 1/3 of our emissions are coming from those existing buildings that are already built. They've been around and they're going to continue to emit unless we do something in order to reduce their GHG emissions. Obviously, new buildings that we're bringing online, we need to increase our housing stock. Everybody's very aware of that, and we're working very hard on that. And that's why any new buildings that we bring online, we're trying to make sure that they're as efficient as possible and as low carbon as possible, both in the embodied carbon in the materials that we're building with, as well as in their operating, not basically electrifying as much as we possibly can where possible. But those existing buildings, they're the big key, because if we look specifically at Ottawa Community Housing, we emit about 27,000 tons in our corporate portfolio. That'll be our Scope 1 and our Scope 2 and our Scope 3. So, and you can see on the left hand of the side of the screen, on the corporate side, the vast majority of those 27,000 tons are being emitted from natural gas combustion on our sites. That's our natural gas boilers and furnaces, as well as our domestic hot water tank or air makeup units. It's the vast heating our space, as well as our domestic hot water, is the vast majority of how we are emitting CO2. And then also we have to consider our tenants. Some of our tenants pay for their own natural gas. They obviously pay for gasoline, as we've seen. And there's also the waste, organic waste that's getting put into landfills, also makes up kind of the entire landscape of these emissions. So when you put those two things together, we represent about 1.2% of the City of Ottawa's emissions. And the goal there is to try and drive that down, specifically in some of our existing buildings. But some of the strategic planning requirements that we have right now in order to reach those targets that we were looking at on that first slide, we've pretty much got to eliminate about 1,600 tons of CO2 every single year. And that kind of represents doing a deep energy retrofit, getting electrifying about 800 homes pretty much every single year. We add to that the fact we were talking a little bit about our stock is getting older. It has some maintenance requirements. We've got about $600 million of capital backlog. We know that we need to bring these units into the future. We need to renew them in order for them to be lasting another 60 years. And when we do that, it's an opportunity to do that reduction in our GHG emissions. So we've got to reach about 96% of our GHG emissions by 2040, and that's how we get our 1,600 tons that need to be eliminated every single year. And we all were also talking, I mentioned that there is also a housing crisis that's taking place right now. We don't really have a vacancy rate. The second a unit is empty, it is turned over and there's somebody else that's renting it. even less than 2 months from when it gets vacant, and there's a 10,000 person waiting list. So we put all of these things together. We need a really innovative solution on how we're going to be able to retrofit these buildings, give them new life, reduce their GHG emissions while the tenants are in place, and also trying to figure out how we're going to finance that. So a strategic deep energy retrofit is going to be the cornerstone of our portfolio. And this is what we were trying to achieve with the Pressland net zero project. So what I'm showing you now is a before and after. The building at 197 to 203 Pressland, 4 units, 3 bedrooms each, built in the 1960s, about $7,200 of utilities annually. And they were emitting altogether about 18 tons of CO2 annually. What you have on your right is the conversion, basically a still 4 units, 3 bedrooms, renewed in 2020 to 2021, net zero energy annually, as well as 0 tons of CO2 emitted annually. And this entire retrofit was done while the tenants were living in place. They basically lived in the construction site, which is why we did it from the exterior pretty much as much as possible. So just a high overview of what we did. We basically have a cutaway of our existing building. We got rid of those eaves in order to put a whole new building envelope around that building. Basically, that means that we went below grade to insulate the foundation. We went above grade, put some brackets to support some above grade panels that gave us an entire new building envelope. We bring that to above the roof line, where we continue a continuous air barrier and add 18 inches of insulation into that on top of the existing roof cavity. So we can put a brand new roof on top, which will also give us a perfect southern exposure and a really good pitch in order to get 35 kilowatts of solar on that southern roof exposure. At the same time, this means that if we improve the energy efficiency, we can get rid of our old natural gas equipment and replace, which you see on the left, and we replace it with heat pump technology, both for our furnace as well as our domestic hot water. And on the right of that picture, you also see the new air handling unit, which basically is providing active fresh air to the unit through a heat recovery ventilator. And all of those changes, now we've changed the building envelope, we've got the mechanical system that's been upgraded. We're talking about the electrical system that also needs to be upgraded in order to account for this new equipment, both the solar that's going on the roof, as well as the mechanical equipment that we're going to be placing in the basement. Now we've electrified what used to be a natural gas load, and therefore we need to upgrade the servicing and move around some of those the meters to the outside. So that is a very high level of how it was done, but 1 second, we're going to see all that work in about 2.5 minutes. So here's a time-lapse video of that work that we completed. So 197 and 203 Pressland, I mentioned that we dug all the way down to the footings in order to expose that foundation. That gave us a chance to eliminate the existing weeping tile, put a fresh weeping tile, address any sort of water mitigation issues, so we know we never have to go down there ever again. We put a water and an air and water membrane that we brought up above grade with 8 inches of insulation stuffed against the foundation. So we've insulated that, we brought it above grade, and there we put a beam that does the perimeter of the building that is going to support our above grade panels, which we're fabricating in the shop right now. So you've got these 20 by 9 foot panels that are basically SIPS panels. So 8 inches of insulation sandwiched between OSB, and then we're going to add a squishy fiberglass layer on the back, and on the front, we're going to finish them as much as possible. So you see us putting the membrane on there, we're putting the strapping on, we're putting the siding on, we're cutting out the windows and the doors, basically making these panels as pre-finished as possible off-site in a prefabrication facility. And then when we bring them on-site, they're basically ready to go onto that building. And actually, in one day, we managed to put up 8 panels that you kind of see in fast motion right now. So there's about 24 of these panels that make up the perimeter. Like I mentioned, this means that we can go into that basement, remove all those natural gas equipment, replace them with heat pump technology, which reduces our the energy that's going to be consumed by the building. As we get above grade, so we've tied that air barrier that's below grade into that above grade panel, and now as we get over, we spray foam the existing roof and we add 8 inches of insulation. So now we've got a whole new building envelope, a nice, very thick insulation and an air barrier across the entire building. And obviously then we get to our southern exposure where we've got a perfect pitch to put up 35 kilowatts of solar to generate electricity. And when you put all of this together, you end up with a new building envelope that reduces the energy that you need in the building, a electrified mechanical system that delivers the small amount of energy that's needed as efficiently as possible, and a solar system on the southern roof that produces as much energy as it consumes in a year, giving us a net zero rating on that building. And so that was theoretical exercise, I suppose, but so we finished it in September 2021, and we've done 1 year of, sorry, my cursor is just being a little silly right now. Trying to get it back. Come on, there we go, perfect. We finished in 2021 and we started doing some monitoring, obviously. So we have our pre-retrofit consumption, which was around 120,000 equivalent kilowatt hours is what that building was consuming before. Post retrofit, our measured performance from September 2021 to August 2022 was just around 40,000 equivalent kilowatt hours. So a 66% reduction in the amount of energy that's consumed by that building. And then our PV generation generated pretty much exactly the amount as that. We had a 45 kilowatt difference between the two, so which is pretty much less than a rounding error. So effectively a net zero building as a result of this retrofit. And we're monitoring various aspects of the performance within that building in terms of the performance of those membranes, as well as the structural integrity and the resilience to moisture of that assembly, making sure we haven't created any pockets of moisture or anything like that. And another aspect that we're monitoring is the CO2 levels within that building to make sure that we've in fact improved the air quality or we've made things better. One of the things that tenants were the happiest about was the fact that now they've got central air conditioning as a result of adding that heat pump into the system. But here you see our pre-construction CO2 levels and then our post-construction CO2 levels when we finally turn on and commission everything. And you can see that we've basically improved about somewhere between 150 to 200 parts per million of difference for the air quality, or at least a proxy for the air quality, which is CO2 levels in that building. Now, obviously, the biggest question that comes, that's fantastic, you managed to do it, it was a pilot. What exactly is the cost of this retrofit, and how are we actually able to pay for it? So the first thing that I like to remind everybody when I get that question is that it actually does cost something to do nothing. And that's what a total cost of building ownership analysis is going to help us realize. So we can actually look at that existing building, and we've got a capital plan for the next 30, 60 years, which outlines the mechanical requirements, as well as the energy that's embodied within that building. So we can see that the existing building, over the next 60 years, you do a net present value of all the costs that are associated with the operation of that building, which includes a lot of natural gas and electricity in its existing status quo building business as usual case, which is the orange portion here. We have the yellow portion, which is the maintenance and repair. So we know we're going to be replacing roofs. We know we're going to be replacing doors and windows and mechanical systems and all that. We've got that spread out over, a 30, 60-year timeline, and we can do a net present value of that. We can also do our property taxes, our home insurance, and we come up with, hey, this building, these 4 units are going to cost OCH over $2.5 million in the next 60 years. So then with that actual baseline, which is not zero, it is $2.5 million, we can then compare it to the actual deep energy retrofit, where we say, okay, well then that net zero retrofit, what does its total cost of building ownership look like? We still have some amount of energy cost. We do have a grid connection fee because we are doing a net metered scenario with our building. So it's not we exchange with the grid, so there is a connection fee associated with it, but much, much less energy expense. That is the bulk of what we're saving for this building over the next 60 years. There is a new cost, that gray area, which is the major building renewal. That is the deep energy retrofit. Some of it is paired up with some of the maintenance and repair costs that we knew we were going to get. That building envelope or that roof, we're trying to do it so you never have to touch that roof ever again. We're using some of the money we knew we were going to spend anyways, maybe upgrading it a little bit. So you end up with a major building renewal, still some maintenance and repair in the yellow there, but definitely smaller than what it was. We could also anticipate maybe this home is now more expensive to insure, and about the same in property taxes. The biggest difference, however, is that that existing building was going to emit over 1,000 tons of CO2 over the next 60 years. And now it is going to emit none of that. So that is a huge savings from that point of view. And it is with those savings, both in the carbon emissions as well as in the energy savings, that we can go and finance these buildings. Because if we're able to, I mean, and obviously there's savings to be had when you're not doing 4 units in a pilot over the COVID pandemic. We're sure that some of these costs would be able to be brought down when you actually get the economies of scale and do thousands of these. But even in this case, we can see that there's $500,000 to be saved that can be reinvested, that can be used to service a debt or to finance this project, but also hopefully reinvested. And just a little bit of an overview in terms of where this money was spent on this project. The building envelope is about a quarter of the expenses. The mechanical, electrical, and some landscaping and remediation, another quarter of that expense. But then the professional services and the labor, basically like the labor for this project, whether it's our staff for project management, whether it's the on-site laborers, or whether it's the professional services, the architects and the engineers, represents about half of the overall cost. So something to keep in mind as we figure out how we need to finance these projects. For anybody that is curious, so this was a project that was done in partnership with Natural Resources Canada. They've used this we're using this project ongoingly as a case study that we're trying to share with as many people as possible, because there is ample amounts of buildings out there, and we're trying to get the word out about this work. And so there is the prefabricated exterior energy retrofit, PEER, which is the acronym for that, project guide that can help you if you were looking at this type of technology. You'd be able to go through this guide and help figure out how engineers can work in the different areas of how we actually get these panelized designs measured, constructed, delivered, and keep them safe, and obviously keep the structure, the hydrothermal integrity of these buildings as we try to overclad them. Now, that was all good and fantastic. You know, we watch a video, we've got a complete project with good results. Sometimes it can seem a little bit simple, but it's really not. And similar to some of the other presenters, we realize as we dive into this that our fields are extremely complicated, right? And we use this schematic in the low carbon training building course that the Climate Risk Institute, where I do instructing. We use this to demonstrate how everything is interrelated and how complex these issues can be. So although we have all the technology and what we saw in these videos, it wasn't, leading edge technology. It was just the bottlenecks right now are more on the financing side, they're on the logistics side, supply, as well as labor. And it's hard to get people to agree on whose responsibility lies where. We have to realize that this building's impact that I just showed you, its emissions didn't start in 2020 or in 2018 when we started the project. They start over 60 years ago when a design team made some decisions for good reasons at the time, but it's been emitting as a result of those decisions for the past 60 years. And it will have an impact, and hopefully a positive emission impact, so negative emissions will continue for the next 60 years. And the same is true for the other millions of buildings in Canada, for the power grid, for the cars that we build, for the mines that we create. All of those things are going to continue to have an impact on our world. So the everyday design decisions are locking in impacts for decades to come. And we have to, so when we look at these projects, we have to look at the long arc of history. And we can quickly realize that we can't expect one project or one country or one government, or especially a 4-year politician, to be the answer. In my opinion, what is required is the vigilance and the due diligence of a group of long-lasted stewards who abide by, a code of ethics that promises to hold paramount the safety, the health, and the welfare of the public, as well as the protection of the environment. And you can see that with that quote from the Engineers Code of Ethics that I think that engineers are the exact group required to get us on that right track, very much as David kind of started the conversation with at the beginning of these presentations. So although climate change and GHG emissions are not explicitly stated in those codes of ethics, it's pretty clear that reporting our environmental impact of any design that we make, as well as the danger to human life that more climate change could result in, that's definitely part of our job. And it's necessary under our code of ethics for us to start accounting for that kind of thing. Obviously, there is so much room for innovation. We need that innovation. And that's how we need to work with all of these different stakeholders that I've got on screen right now in order to address the challenges, especially when we're looking at existing buildings, but all of the different innovation that needs to take place. And I really do believe that engineers can be the agent of change, because we end up at the center of these discussions because the clients or the designers or even other stakeholders, they look to us to figure out what's technically possible. And they rely on our expertise to bring those solutions to life. So we have to be at the forefront, in all honesty, with all of those passive house developments. OCH asking different engineers and different architects to step up and give us these high performance buildings that didn't exist before, that they'd not done before, they required them to get trained up for, is how we've helped move the industry a little bit forward. Similarly with these innovative deep energy retrofit projects. So with that, just a little bit of a reminder that, you know, our society is only going to go great. We're going to plant some trees that we're never going to enjoy their shade. That's something that we have to realize, and we have to look at these projects. The decisions that we're making today will last decades, and we have to look at them in that long arc of history. So voila, I think I managed ish to say all my 20 minutes. But thank you very much. Thank you to the organizers. Thank you for everybody for attending, and I'm happy to take questions, but I'm pretty sure we're out of time.
Okay. Good evening, everyone. I believe we're doing the concluding remarks now. If not, please let me know and jump in.
Go ahead, Christopher, Vice President of the PEO.
Thank you. So good evening, everyone, and thank you again to all of our speakers for the insightful seminar. I do want to thank all those who've attended as well. I want to start by retelling everyone, engineers are mandated to protect the public welfare with their engineering. And now more than ever, the world is looking at engineers to address the climate action issues, the resistability issues. And I would also say that we should look to one another and not just the public to address action issues in our everyday practicing. So fun fact, there are about 51 disciplines in engineering that you can apply for at PEO in Ontario. And we're living in exciting times and interesting times at PEO, and we are seeing more and more emerging disciplines. It's my personal dream to see a discipline in engineering specific to climate change, resilience, or some sort of engineering or sustainability that we haven't seen before in Ontario. And what we've heard today is just innovative minds coming together. And I want to thank you all for that. I do want to highlight, once again, the Engineers Canada National Guideline on Sustainability Development and Environmental Stewardship for Professional Engineers. You can just Google climate action and Engineers Canada to find that guide. Very insightful. Once again, I want to thank our speakers and thank those for attending.
Thanks very much, Christopher. Christopher is the Vice President of the Professional Engineers of Ontario, and great to have you giving greetings and closing remarks. I'm going to be real fast. I'd like to thank the speakers, all 4 speakers, the volunteers. There's quite a number of volunteers who did a great job, and the sponsors. There will be a survey going out to participants of this seminar. And one of the things that's going to be asked, and the leadership came up in this seminar several times, and they need to be good communicators. There are 2 speakers clubs that are associated with the engineering community. Amanda, the chair of the committee, is the president of the Toronto Engineering Club of Speakers Toastmaster Club, and I'm the president of the SCORE Toronto Metropolitan Toastmasters Club. And that's what we try to do, is provide an opportunity to develop communication and leadership skills, especially to people in the engineering community. And you will have an opportunity in that survey to put down your email address if you want to get invited to a meeting. So with that, I'm going to conclude the meeting and thank everybody for coming. Hope you enjoyed it, and come to the next seminar we will be having in about 2 months. Bye now.